Hello friends, welcome to Independent Learning. My name is Raj Shah and we are starting with a new chapter which is basic concepts in geometry. Okay, and in this video we are going to learn about the basics of what is a point, line and a plane. The next will be how to find coordinates of points and the distance between any two points on a number line. Okay, and to find the betweenness. Okay, like which point is in between the other points. Okay, so we'll be finding that. So let us start the first topic, which is what is point, line and plane. Okay, so before starting with that, I want you to know what is a dimension. Okay, so zero dimension, it says it has no dimension, meaning has no length, breadth and height. It has no length, breadth and height. Now, if you think of the example for this zero dimension, it is a point. So, just a dot. That's it. That is a point is of zero dimension, meaning it has no length, breadth or height. Okay. So, one dimension is which has just length. Okay, which has just length. So if you see what is a line, if I draw a line, okay, this is a line. I can find the distance or the length of this line, correct? So that comes under 1D. For example, if I draw this as 0, -1, 1, 2, okay, so this is a number line. So if I want to find at any point, if I want to find the length, I'll be able to find. So this is just what is called 1D or one dimension, which can just give you the information about length. Okay, so that was about line. Okay, so line, we can say it's a one dimension structure or one dimensional figure. Okay, then coming to the third one, which is 2D. So 2D is a figure which involves length and breadth. Like for example, we can say a rectangle or a square. Okay, we can give example: rectangle, square, circle, okay, and any type of quadrilateral. I've written this in short, quadrilateral. Now just imagine about this full board itself. Now can we say this white board itself as a 2D structure? Yes. Why? Because it is a rectangular shape. Or you can say about this, we can also say that it is a flat figure. So any figure which is flat, or you can say which can be drawn on a particular surface, is called a two-dimensional figure, which is our plane. So on a single plane, which is this board, we can draw a square or circle, okay, rectangle, triangle, whatever. So that is two-dimensional figure, and the examples are these. So basically, we did zero dimension, which has no dimension, okay, which is length, which has no length, breadth, and height. Then we saw what is one dimension, which is about line or the number line, we can say, which has just length. At any particular find, we can only find length but not breadth or height. Okay, so that is about one dimension. Now, what is two dimension? It is a flat figure. Okay, so a flat figure, it can be any figure which is like circle, square, quadrilateral. Okay, so that is a flat figure. For example, that is plane. So this comes under 2D structure, comes under a plane. Okay, 1D is about line. So I'll just write this or over here. Point, this is about point. This is about line and this is about plane. Okay, now if you think about this 3D structure, you might be knowing this. For example, if I say cube, it has all three: length, breadth and height. It has all three. Like for example, if I draw, okay, this is a rectangle which is a 2D structure. Now I'll convert this into a 3D structure. Let's see how. Okay, so this is a 2D 3D structure. So this is a cube or a cuboid, you can say cube or cuboid. Okay, which is a 3D structure which has length, breadth and height. So we are not going into the depth of this because this we don't have in the chapter. Okay, so if it comes anywhere further in the syllabus, we'll be taking this also. Okay, so this is about 3D structure, which for example you can say your book, the notebook or your textbook, it is having both length, it is having all three, which is length, breadth and height. So it is having all three parameters, so it is called 3D structure or 3D figure. So we discussed about all these. Okay, so now we'll see what is coordinates of a points and distance. So basically in this chapter we are discussing about coordinates of points, meaning we are discussing about lines or a number line. Okay, so on a number line we are going to find the coordinates of points. So now we are starting with coordinates of points, okay, and distance. So let's see how to find coordinates of points, any point which is given to us. Like for example, in this, if you want to find, let's say, coordinate of D. So for D, for point D, okay, point D, coordinate can be found. We can say, see, on this number line, at 2 D is named, so D will be, coordinate of D will be 2 units. Okay, so we can say coordinate is 2 units. Okay, if let's say, let's take for example Z. So for Z, for point Z, coordinates, okay, or coordinate is -3 units. A coordinate of point O, so that will be 0 units or 0 unit. Okay, so what are we doing here? We are trying to find the coordinates of each and every point which is being named. So the point, for point D, we found it as 2 units. So on the number line from the origin, point D is at 2 units, okay, away from the origin. Okay, same way point Z is -3, meaning on the left hand side and at 3 units away from the origin. That's what this means. And point O is at the origin because it's 0 unit. Okay, I hope you have understood what I said. So this was to find coordinates of points. So here we are finding how to find the distance between any two coordinates. Okay, so to find distance, let's take for example distance between D and E. So distance DE. Okay, so this is written, distance between DE, it is written like this, D and in the bracket D and E. Okay, so this will be, this can be written as so Distance DE can be found by coordinate of E minus coordinate of D. Okay, so I hope you have understood this. What do we say? To find distance, we subtract the coordinate of the higher one, because coordinate of E is 4 and coordinate of D is 2. So E ka coordinate is bigger, so coordinate of E minus coordinate of D. Because we do not subtract smaller minus greater, correct? We always do greater minus smaller. So we do this way. Therefore, this will be coordinate of E, you know it is 4, okay? It is 4. So 4 minus coordinate of D is 2. So 4 minus 2 is 2. Okay, let's take one more example. Now let's say we want to find distance between Z and D. So to find distance between Z and D, again you write this itself, coordinate of D. Why are we writing D here first? Because D ka coordinate is greater than the coordinate of Z. Correct? As you can see from this number line itself. So we can say coordinate of D minus coordinate of Z. Therefore D is 2. 2 minus, so it is 2 minus Z is minus 3. Okay. Now minus into minus is plus. This we have studied in the lower standards. Okay. So this will be 2 plus 3, which will be giving us 5. Okay. So I hope you have understood. I want you to find distance AO. Okay. So this will be coordinate of O minus coordinate of A. Okay. So I hope you will be able to solve this. Now we'll take another topic, which is betweenness now. So let's see what is betweenness. Okay. To understand betweenness, let's take P, Q, R. Okay. 3 points such that they are collinear. Okay. So we are taking 3 points P, Q and R. They are collinear also. Okay. Now if you try to draw these 3 points, how are we going to draw it? This is one of the way, P, Q, R. Okay. Keeping Q in between P and R, then we can draw P, Q, R. Okay. So there are 3 possibilities for drawing P, Q, R. Okay. They are collinear also. Okay. In all the 3 possibilities. And here in this, if you see, Q is in between P and R, correct? Here in this, P is in between Q and R. So let's write them. Q is between P and R. Okay. Now here in this, P is between Q and R, correct? And here in this, R is between P and Q. Okay. So these are the possibilities which we can see. Now what is betweenness? As the word suggests, it says that any point which is in between the other 2 points, that is called betweenness. Now if we can, okay, this can be written, this betweenness can be written like P, Q and R. Okay, this can be written as Q, P, R. Okay, this can be written as P, R and Q. Now why are we writing this? This is how you represent betweenness. Okay, so this says that Q is in between P and R. This says that P is in between Q and R, and this says that it is r which is in between p and q. Okay, let's see one more thing. Let's consider this first one. Okay, so the first one which says PQ, Q is in between P and R. Now, if this is happening, okay, P, can you find distance PR from this? P, distance PR will be distance PQ plus distance QR equal to distance PQ plus distance QR, correct? So if this is happening, okay, if this statement which we can say is happening, then we can say that there is betweenness which is occurring. So if this is happening, then okay, then we can say, see, PR, right? PR is equal to PQ, so PQ plus QR, correct? So we can say here in this that PQ and R means Q is in between P and R, because here it says PR. Now if I, let's say, if I want to find distance QR, okay, let's say if I want to find distance QR, how can I say it? Distance QP plus distance PR. Now here, the one which we take on the left, those are the two extreme points, means the end points of a line. You can understand from this itself. So QR is equal to QP and PR. Okay. So here, if this is happening, we can say, if this, then we can say that Q, then comes P, because QP then PR, correct? QP and then PR. So we can say P is in between Q and R without looking at this. Okay, without looking over here, we can directly say, by finding distance, we can find the betweenness. Okay, like for example, which point is in between which other points. Okay, like for example, if I say, let's take one different example. Let's say if distance AB is distance AZ plus distance ZB. So what does this say? If distance AB, so I told you, if that is happening, then AB will be at these 2 points. AB will be this. Okay, then AB is AZ plus ZB. So AZ, which is this distance, plus ZB, which is this distance. Okay, so if this is happening, then we can say from here that AZB, meaning Z is in between A and B. Okay, I hope you have understood what is betweenness, how to find betweenness. Okay, so this is the condition, the prime condition to show whether 3 points are following betweenness or not. And also, if we are able to prove that it is betweenness, there exists betweenness between 3 points, we can also say that those 3 points are collinear also. Okay, so let's see some examples, okay, based on these concepts which we did. Okay, what is, how to find coordinates of point and distance, and also examples on betweenness, and you'll be able to understand these concepts better, in a better way. Okay, so let us start. Okay, let's take this example and we'll try to figure out some more details on betweenness. Okay, now let's say in this itself, if I want to find ZB, distance ZB, which is to be found. Okay, so how can I find distance ZB? So I can say, let's take, okay, let's take some example. Let's take distance AB is 6 and distance, okay, in this itself Distance AB is 6 and distance AZ is 2, and we have to find distance ZB. Okay, so this is given to us. Okay, and it is said that A, Z and B. So this is given, Z is in between A and B. Okay, so this is the given question. So how can we find it? So how are we finding this? We can say distance AB is distance AZ plus distance ZB. Okay, when AZ is to be found, it's given as 2 plus distance ZB, okay, is to be found, and distance AB is 6. So distance ZB is 6 and the 2 goes this side. So 6 minus 2. Okay, this is what we get. That is 4. Okay, so I hope you have understood how and what we did. Now let's take one more example for betweenness, which says let's take P, X and Y. Okay, now it is given Px is equal to xy. What does this mean now? Px and xy is equal. So this means that z is the midpoint, or it can be wrote like x is the, so this is another question. Midpoint of Zx is the midpoint of Py. Okay, so x is the midpoint. If x is the midpoint, then Px and xy, so this distance and this distance, are equal. Okay, if Py, okay, Py, this whole distance is, let's say, 10, we have to find xy and Px. So how are we going to find this? Let's see. Distance Py, okay, distance Py is equal to distance Px plus distance xy. Okay, now Py is 10 here, Px and xy, they both are same, so we can say instead of Px I can say xy. So this will be written, instead of Px I'll write xy here plus distance xy. Correct? Now here this is 2 times, so it is like, oh, this is one thing and this is that same thing. So if you add, it's like one apple plus another apple, so that will be 2 times of that apple. So that is 2 times distance xy, which is equal to 10. Therefore distance xy is 2 comes this side below 10, so 10 upon 2, which is 5. So distance xy is 5, and also therefore we can say distance xy we have found, we have to find px, so distance px is also 5. Okay, so that was some variety in betweenness itself, question based on that. Okay, now we'll see some more examples. So let's solve some more examples based on the topics which we did. Okay, so the first question, it says a is x, b is y, and we have to find distance AB. Okay, so pretty easy one. Okay, we should be able to see x is 2 and y is 7. Okay, for A. So if you want to find distance AB, Okay, distance between A and B. What is B here? Y, and A is X. So we can say coordinate of B minus coordinate of A, but coordinate of B is what? Y. So it will be Y minus X. Therefore, Y is 7 and X is 2. So it will be 7 minus 2, which is 1. Okay. Same way for this, the other part, which is part B, we can find distance AB. Same way, Y minus X. So that will be 4 minus 1. Okay, so minus into minus, you know that it's plus, so 4 plus 1 equal to 5. Okay, so I hope you understood the first question. Let's see the next one. Let's see first this B and then we'll see for A. Okay, if we see B, which one is the biggest one? It's AB. So we'll say distance AB equal to distance AC, and we, if you see 14, this is 14, right, the biggest one, and then keep that bigger one on one side and the smaller ones you add and you put it on the other side. So add AC and CB, so distance AC plus distance CB. Okay, or put it this way, so distance AB is 14 given to us. Now take the other two and add them. Let's see what we get. So distance AC plus distance CB, which is equal to 6 plus 8 equal to 14. So see, if you see distance AB and the sum of these two is same, 14 and 14. Correct? So we can say that distance AB is equal to distance this and plus this, the distance AC plus distance CB. Okay, so I hope you understood how you find this. You take the bigger one, okay, keep that as that what is given, and then add the other two smaller ones. If we get this same, okay, this and this, then you can write it this way. If you can write it this way, we can say, if you remember betweenness, we can say that AB is at two extreme points and in between there is C. So AC plus CB. So this will be C. Okay. So we can write, if this is happening, then we can say A, C, B, meaning C is in between A and B. Okay. So we have proved that there is betweenness. Okay. Where point C is between A and B, and also these 3 points are collinear. Okay, so the question says whether it is collinear or not, and to find which point is in between the other two. Okay, so we can also say that this is collinear. Okay, so let's see the second one, the first one, sorry, this part A. So let's see, same way, which one is the bigger one? Actually the biggest is RS. So distance RS is equal to 8. Okay, now let's add the other two. So that will be distance ST plus distance RT, which is equal to 4. I mean 6. Okay, ST is 6, RT is 4. So 6 plus 4 equal to 10. Now if you see like this, it is not happening. This is 8 and this is 10. Okay, so if these two are not equal, okay, distance RS not equal to, okay, not equal to distance ST plus distance RT. Okay, so they are not equal, therefore we can say does not exist, and also we can say R, S and T, all 3 points, okay, R, S and T. So also we can say that R, S and T, all 3 points are collinear. Okay, so I hope you understood this. Let's see the third one, the last one, and we'll end this topic here. So if A, B, C, okay, this is given to us. So the solution part will be A, B, and this is C. So distance ABC. So AC is at extreme point and B is in between. So we can say distance AC, this whole, is equal to distance AB plus distance AB plus BC. Now what are we supposed to find? Put the values of them, whatever is given to us. Distance AC 11, AB is to be found. Okay, distance, instead of distance you can write L also, which is saying length. So it doesn't matter whether you write distance D or length, okay, it means the same. So distance AB we need to find, plus distance BC is 6.5, so 6.5. Now what will this be? 11 minus 6.5, the 6.5 comes on the left hand side, equal to distance AB. Okay, now you just switch it like this, like you keep this pen like this, okay, you can switch it. Therefore we'll say distance, you'll write distance AB on the left hand side, okay, switching the equation. Left side becomes right side, becomes left side, and the left side goes on the right side. So 11 minus 6.5 at the same time is, okay, 3.5. So I hope you have understood how we do this. Distance, if you want to find any one distance which is unknown, can be found using betweenness. Okay, so I hope you have understood this topic. We discussed what is point, line and plane in terms of dimensions. Okay, we saw what is how to find coordinates of points and distance between them, and also we discussed about betweenness. Okay, so we end this topic here, and in the next video we'll continue with the new concept on this same chapter. Okay, so if you understood the concept which I taught you, okay, make sure that you share it with your friends. Okay, thank you for watching.